Hi folks, I'm just making this quick screencastify for you because I want to show you um, this tool of using Desmos in order to do parametric equations. For some of you who are absent, for some of you who are on the other side of the room, so the details might have been hard to see. So I thought I would just make this quick video. So the way that we do this, and actually I want to show another tip or trick that I didn't show in class. So we have our window here. And I've gone to desmos.com /calculator. And all I'm going to do is come in here and put in our parametric equations. And the way you do it is parentheses. And what we're doing is putting in the x of t comma y of t. So whatever your x of t is, let's say it's 3t to the fourth, whatever. And notice this add slider that popped up. We're going to come back to that in just a minute because that's a neat little trick. And then we'll go, let's say, negative t cubed. Negative t cubed. Right, and that's our parametric. And so there you go. There's the path that plots it. Notice that here it says from 0 to something. I can change that to another value, and it gives us a bit more of the picture of what that looks like. So there we go. Just in terms of what we're seeing this as not a parabola, but as a curved figure. And this curved figure opens up left-right because the order of the highest term is the x. And that makes it open up left-right because because it's positive. That's why it's opening up rightward. Notice what happens here if I put a negative sign there. It opens up leftward. So the sign of the highest term is what's going to determine the direction of the concavity of that graph, whether it's left, right, up, or down. And then you'll notice here, because the y parameter is always going to be negative because we only care about positive times, that's why it's below the y-axis. All right, so now I'm going to get rid of this, and I want to show you that other little thing. So here we go. Let's say our parameter here, our parametric equation, is t squared, and I'll keep this. I'm going to click this button there. We'll go back to our equation, comma, and let's say it's negative t squared. So we should know, oops, that's a t squared. So we should know this is going to be a line. But you notice it didn't give me anything. Instead, what I have here is this slider bar, and what happens here is I can move it around and we can see what the motion is. In fact, if I play it, you can see, and it'll play from 0 to, it'll go actually from negative 10 to 10. I can actually change that, the speed of the slider bar there, or the animation mode if I want to, or I can go on step here. So I'm going to constrain it to be from 0 to, say, 100, and I can have that step be, every 0.5. And so if we play it now, you can see what's going on. So kind of interesting there that we can see this. Notice that the path of this is going to be a line, but you can actually watch it speed up along that line by looking at how those steps go, right? Notice if I went back here and I moved this and just made it t and t, and I did the same sort of, oops, oh, it still thinks there's powers there. Let me get rid of that. Okay. You'll notice then that that point is moving at a constant speed there, rather than that speeding up, because we saw the point traveling further and further in the same step of time. So this is a really interesting way of animating the question, is it moving at a constant speed, and really seeing in real time how it moves along that path. So we can get rid of this as we want, click there, and it gives us back to the actual path itself. So we can plot the path. We can see a particle moving on that path by using the slider bars. So there's a lot of really interesting things that you can do with Desmos that helps us take parametrics and allow us to really visualize the motions that they represent in the Cartesian coordinate plane. So hope this little